Myself V. Akshit Reddy. Present I am pursuing my engineering in Institute of Aeronautical Engineering, ECE branch. And today's my course name is Satellite Communication. Today's topic is Explain the importance of satellite footprint in Earth station planning. Introduction to satellite footprint. Satellite footprint defines the geographic area where a satellite signal can be received or transmitted. It is a crucial factor in planning earth stations, locations, and coverage. Understanding the footprint helps optimize communication efficiency and service quality. What is a satellite footprint? The satellite footprint describes the ground area covered by the satellite signal. It varies depending on satellite altitude, antenna size, and frequency band. The footprint can be regional, continental, or global in scope. Importance of coverage area. Adequate coverage ensures reliable communication links within the desired service region. It influences the placement of earth stations to maximize connectivity. Proper understanding of coverage helps avoid service gaps or overlaps. Frequency bands and footprint size. Different frequency bands C, Ku, Ka produce varying footprint sizes. High frequency bands tend to have smaller, more focused footprints. Lower frequency bands generally provide larger coverage areas. Satellite altitude and footprints. The altitude of satellites affect the size and shape of the footprint. Geostationary satellites have fixed footprints over the equator. Low Earth orbit (LEO) satellites have dynamic and smaller footprints. Earth station location planning. The satellite footprint guides where to position Earth stations for optimal coverage. Locations are chosen to minimize signal loss and ensure clear line of sight. Proper planning reduces the need of multiple earth stations in the same area, ensuring signal strength and quality. Knowing the footprint helps in selecting sites with minimal interference. Proper placement enhances signal strength and reduces latency. Adjustments to site location can optimize overall system's performance, reducing cost and infrastructure. Accurate footprints analysis can lower infrastructure and operational costs. It prevents unnecessary development of earth stations outside the coverage area. Efficient planning leads to be better resourcing, uh, utilization, and cost savings. Handling overlapping footprints. Overlapping footprints can provide redundancy and increased reliability. Planning for overlaps ensures seamless coverage during satellite handovers. Managing overlaps requires precise earth station placement and coordination. Dealing with shadow areas. Shadow areas are regions outside the satellite footprint with no coverage. Identifying shadow zones is essential to avoid service interruptions. Excuse me, sorry. Additional earth stations or satellite configurations can mitigate shadow zones. Impact on network design. Satellite footprints influences network topology and architecture. It determines the number and placement of ground stations needed. Proper footprints consideration enhances network resilience and scalability. Regulatory and license considerations. Coverage areas must comply with regional spectrum and licensing regulations. Satellite footprints planning aligns with nations and international policies. It ensures legal operation and minimizes interference issues. Satellite footprints and service quality. Large, well defined footprints improve service consistency for users. Precise planning reduces signal degradation and dropouts. It helps meet service level agreements and customer expectations. Technological advances and footprint optimization. Modern antenna technology allows for more flexible and narrow footprints. Sorry. Spot beams can target specific regions, improving capacity and quality. Adaptive footprint management supports dynamic coverage and adjustments. Case study: Geostationary satellite footprints planning. Geostationary satellites provide fixed footprints ideal for regional coverage. Planning considers population, density, and demand with the footprint. Proper site selection maximizes coverage and minimizes interference. Case study: LEO satellite footprints planning. LEO satellites have smaller, rapidly changing footprints requiring dense constellations. Earth station networks must be flexible to track moving satellites. Footprints analysis ensures continuous coverage and service reliability. Future trends in satellite footprint planning. Advances in beam steering enable dynamics and tailored footprints. Integration of AI and data analytics improves footprint optimization. Continued innovation will enhance global coverage and connectivity. Summary of key points. Satellite footprints is fundamental to Earth station planning and network design. It impacts coverage cost, signal quality, and regularity compliance. Accurate footprint analysis ensures efficient and reliable satellite communication systems. Satellite footprints and service quality. Large, well defined footprints improve service consistency for users. Precise planning reduces signal degradation and dropouts. It helps meet service, legal agreements, and customer expectations. Technological advances and footprint optimization. Modern antenna technology allows for more flexible and narrow footprints. Spot beams can target specific regions, improving capacity and quality. Adaptive footprints management supports dynamic coverage adjustments. Case study: Geostationary satellite footprints planning. Geostationary satellites provide fixed footprints ideal for regional coverage. Planning considers population density and demand with the footprints. Proper site selection maximizes coverage and minimizes interference. Summary of key points. Satellite footprints is fundamental to Earth station planning and network design. Sorry. It impacts coverage, cost, signal quality, and regularity compliance. Accurate footprint analysis ensure efficient and reliable satellite communication systems. The conclusion: understanding the satellite footprint is essential for effective Earth station deployment. Proper planning enhances coverage, reduces cost, and improves service quality. Ongoing technological developments will continue to redefine footprint utilization. Thank you.